All right, answers to AP test review number 2. Number 1 is a calculator problem, so make sure we're using our calculator. Particle moves along the x-axis with a velocity at time t greater than or equal to 0 of v of t. Find the acceleration, so make sure we show them we know that v prime of t equals a of t, and then we're just going to plug it in our calculator. So I'm going to enter this on a graph page. Once it's entered on a graph page, then I'm going to add a calculator page. Once I get it on the calculator page, then I'm going to do shift minus. I'm going to plug this in, then I'm going to do that vertical bar, and then I'm going to go x equals 3. When I do that, that gives me my velocity. Speed of the particle, is it increasing or decreasing at t equals 3? Remember, if you're going to talk about whether or not speed is increasing or decreasing, I need to look at the velocity and I need to look at the acceleration. We just saw that the acceleration is negative 0.135. Velocity on that calculator page, all you have to do is press that F1 or press variables to get F1, stick 3 inside of it, press enter, it's going to give you that. Notice that both of these signs are the same, so that means that speed is increasing, so make sure we justify that. Find all values of t, which the particle changes direction, so that means we need to set velocity equal to 0 and then do a sign line. Or actually, we have a calculator, so we can just look at the graph. So make sure you show that you're setting the velocity equal to 0, and then you look at the graph, and it crosses the x-axis at 1. And so our justification is because v changes sign. So if I have a calculator in my hand, I don't have to do a sign line. I can just look at the graph and then from the graph give my answer. Find the total distance traveled by the particle over the time interval. Whenever you see total distance, that means we have to integrate the absolute value of velocity. If it said displacement, then it's just velocity. But if it's total distance, we want the absolute value of velocity. So we're going to integrate that from 0 to 3. My calculator could do that for me. All I have to do is punch this in. Again, instead of v of t, you can press the variable button, put f1 of x in here, press enter. It's going to give me 1.853. All right, number 2 is just a product rule. So I've got first, I've got derivative of the second plus the second times derivative of the first. Derivative of the first is just going to be 1. My 2's reduce, and I move my x to the top. I get a common denominator. Put my like terms together. I get 3x minus 3 over the square root of 2x minus 3. So answer A. On 3, if a to b of f of x equals a plus 2b, then what does a to b of f of x plus 5? So I did this in pieces. So I did just this piece right here, and it says that's equal to a plus 2b. So that's what I did. And then on the other one, we have the integral from a to b of 5. So you can do this one of 2 ways. You can integrate and get 5x and then plug in b and a. Or you can just understand that if I'm integrating just a constant, it's 5 times the difference. So either way, you're going to end up with 5b minus 5a for that piece. Put my like terms together, we get 7b minus 4a. Number 4, this is just asking for the derivative. Make sure we understand that this 2 is on the outside of all of this. So it's cosine x cubed and then parentheses squared. So we have to know that when we're doing the chain rule. So I'm bringing the 2 down. There is a 1, understood 1 right here. Inside stays the same. Take the derivative of cosine, which is negative sine. Inside stays the same. And then derivative of x cubed gives me 3x squared. So 3x squared, the negative, and the 2 gives me negative 6x squared. Cosine x cubed, sine x cubed, so we like D. 5, equation of a tangent line. Again, as soon as you hear tangent line, you should be thinking slope and a point, and you should be getting your slope from the derivative. So I'm going to take the derivative of this. Derivative of cosine is negative sine. Derivative of 2x is 2. Make sure the inside stays the same here. So there's my derivative. I need to plug in pi over 4. So I plug in pi over 4. 2 times pi over 4 gives me pi over 2. Sine of pi over 2 is 1. Negative 2 times 1 gives me negative 2. They gave me an x value. They did not give me a y value, so that means I need to plug back into the original to get a y value. I plug in pi over 4, turns it into pi over 2 on the inside. Cosine of pi over 2 is 0. So y minus my y value equals my slope, x minus my x value. So my answer is E. All right, let f be the function defined for all real values of x, where f prime of x equals that, then f is decreasing on the interval. Just a second. All right, so that's my derivative. I'm going to set that equal to 0, which I did here. And from the top, when I set the top equal to 0, I'm going to get 2 and negative 2. I get 2 from the bottom as well. So I do a sign line with everything. Since it's absolute value, I want to make sure I plug in for everything. So I plug in a 3. We know the top is always going to be positive. So I plug in 3 on the bottom. It's going to be positive. So positive over positive gives me a positive. I plug in 0. Again, top is positive. Bottom is negative. So I get a negative. I plug in a negative 3. Top is positive. Bottom is negative. So we get a negative. So when is it decreasing? It's decreasing less than 2, which is going to be right there. 7, let f be a differentiable function such that f of 3 equals 2 and f prime of 3 equals 5. If the tangent line to the graph of f at x equals 3 is used to find an approximation of a 0 of f, that approximation is. So when you read that, again, there's a tangent line again, so that means slope and a point. They gave me my point. They also gave me my slope. So I can go ahead and write my tangent line. Y minus 2, y minus my y value equals my slope, x minus my x value. Now we want to do a 0 approximation, so that means we want to plug 0 in for y. And then we're just solving. So I add the 15, gives me 13. I divide by 5. I get 13 over 5, which is 2.6. All right, number 8, the graph of f consists of 3 line segments. So we've got 3 different line segments. It says let g be the function defined by the integral from negative 4 to x of f of t. We want to find g of negative 1. We want to find g prime of negative 1, and we want to find g double prime of negative 1. Find the value or state that it does not exist. So for g prime of negative 1, I'm just going to plug negative 1 in here. So we're going negative 4 to negative 1. So I've got a rectangle that is 3 by 2, so that gives me 6. I've got a triangle that is 3 by 1, so that gives me 3 halves, or 1.5. So I have 6 and 1.5, which is 7.5. But it's under the x-axis, so it's going to be negative. For g prime of negative 1, I need to identify what g prime is. Second fundamental theorem of calculus tells me to just plug in my x and multiply by the derivative of x, which is just 1. So g prime of x is f of x. So to find g prime of negative 1, then that means we want f of negative 1. So here's negative 1. There's my f value, which gives me negative 2. So then I take the derivative again to get g double prime. So derivative of g prime gives me g double prime. Derivative of f gives me f prime. So that means g double prime of negative 1 equals f prime of negative 1. So if I have the graph of f and I want f prime, then that means I'm looking for slope. And we want the slope at negative 1. The problem is at negative 1, I've got a sharp turn. I've got a cusp, and at a cusp, we know that the derivative is not defined, so we're going to say that it does not exist. So g double prime of negative 1 does not exist. B, for the function g defined in part A, find the x-coordinate of each point of inflection on the interval. So points of inflection happen where the derivative changes from increasing to decreasing or vice versa, and that only happens right there, so that's the x value of 1. So x equals 1 because f changes from increasing to decreasing. Pretty simple stuff there. C, let h be the function. So I've got another function that's using f. So let h be this function. Find all values of x in the closed interval from between -4 to 3 for which h of x equals 0. So I want this thing to equal 0. Well, automatically I should know that if I plug 3 in, that matches up. So 3 is automatically going to be one place where I get 0. The other thing is, remember, a definite integral represents the area under the curve. So that means I want my area under the curve to be 0. So that means I want my positive area to balance out with my negative area. So if I start at 3 and I'm going backwards, I notice that this piece and this piece are the same. So that means if I integrate from 3 to 1, I'm going to get 0, since both of these areas are the same. One's positive, one's negative. So far, 3 is going to give me a 0, and 1 is going to give me a 0. If I keep going, this piece and this piece are also the same. So that means they're going to cancel each other out, and I can get to -1. So that means my 3 values are -1, 1, and 3. And I didn't write 3 down. I should have. Looks like I missed that. So we need to add 3 to that mix as well, because if I plug 3 in there, that's automatically going to give me a 0. All right. And for the function h, we want to know when h is decreasing. So h is going to be decreasing when its derivative is negative. So I need to find the derivative of this. Notice my variable's in the bottom here. So that means when I plug it in, I'm going to have a negative out front since it's in the bottom. So that means the derivative of h is going to be negative f of x. So I get negative f of x. So if I want h prime to be negative, then that means I want f to be positive because of this negative. This negative is going to turn f. When f is positive, it's going to make it negative. When f is negative, it's going to make it positive. So in order for h to be decreasing, that means h prime needs to be negative, which means f needs to be positive. A little bit confusing there, but I think you can handle it. So the only place f is positive is between 0 and 2. So that means h is decreasing between 0 and 2 because f is positive, which makes h prime negative. All right, number 9, not much going on here. You can do a u for 3x. The derivative of 3x gives me 3. I divide by that, so that's where the 1/3 comes from. Okay, if it's something simple like this, I usually just do it in my head. I take the derivative and then I divide by it, which is what I did. And if I integrate sine, I get negative cosine, and then it's a matter of plugging in pi over 3 and 0. So if I plug in pi over 3, that gives me pi. I plug in 0, that gives me 0. So cosine of pi we should know is -1. Cosine of 0 is 1. That gives me -2. I multiply by -3. That gives me the positive 2/3. All right, number 10, table of values. We want to do 4 equal subintervals, and we want to do a trapezoidal approximation. So we're going to have the 1/2 out front. Then I need the distance between the x's times the y's added up. So the difference, the first one, I'm going to have 0.5, and then I'm going to have 6. So 0.5 and 6. Second one is going to be 0.5, and 3 plus 5 gives me 8. Third one is 0.5, and 5 plus 8 gives me 13. Last one is 0.5, and 8 plus 13 gives me 21. I work all that out. We end up with 12 as our answer. All right, the next one, I would recommend moving this one up and making it x to the -3 and then integrating it. When you do that, you get -1 over 2x squared. Plug in the 2. Plug in the 1, you're going to end up with 3/8. Pretty straightforward problem. 12, we want to find the derivative. Looks like I did the quotient rule. You could also, if you wanted to, put this whole thing in parentheses and move it up to a -1 and then do chain. Looks like I just thought it was easier to do quotient rule. So we have bottom times the root of the top minus the top times the root of the bottom over the bottom squared. And so this goes to 0. I get a -6x on top, and I get a 4 plus x squared on the bottom. So it matches up with A. 13, we want a relative maximum. So that means I need a critical point, and then I need to know where it changes from positive to negative. To get a critical point, we're setting the derivative equal to 0. I factored out a 3x, so that means my critical point is going to be 0 from the 3x, and it's going to be 2 from x minus 2. Put that on the sign line, plug in each section. We see that it's positive, negative, positive. Remember, when you're plugging in for a sign line, you always plug into the derivative. You don't use the original. Remember, the only time you use the original is when you need something you don't have. All right, we want a relative maximum, so that means we need to change from positive to negative, so that means our relative maximum occurs at 0. Okay, and remember, if this said maximum value, remember you would have to take your x value and plug it into the original to get a y value. Remember, if you see the word value, that means it wants a y value as an answer, so don't forget that. All right, 14, take the derivative of this thing. So I changed that to x to the negative 3. So if I take the derivative, it's going to end up giving me negative 3 over x to the 4th. I change this to x to the negative 1, take the derivative, gives me 1 over x squared, and derivative of x squared is 2x. Plug in negative 1. Negative 1 here is going to be positive, so it's going to be a negative 3. Negative 1 here is also going to be positive, so that's going to be 1. Negative 1 here turns it into a negative 2. I put the negative 3 and the negative 2 together to give me a negative 5. I add the 1. That gives me my negative 4. All right, so that is answers to AP test review number 2.